Welcome back to microeconomics. So this week we will look at several different types of game. The first is the mixed strategy. So last week we looked at the first very simple game in which players choose one action or the other with certainty. And in that setup, we called it pure strategy. When players play with certainty, one or the other strategy. However, there may also be the case that he or she will play mixed strategies. What does that mean? So the mixed strategy means that they randomly select from several possible actions. They randomized their strategy. Some examples of randomization are, for example, when you toss a coin and then you decide between two strategies, depends on what show which face of the coin appears after tossing. It's like head or tail. Or you toss a dice, decide among 6 possible strategy. Or like in soccer's penalty, the one who does the penalty can randomly choose between shooting to the left or to the right. So those are some examples. Another example may be relevant for you with the upcoming exam now. I want you to take the exam as an opportunity to review all that we learned during the course so that some knowledge will stay with you for further modules because necessary is the fundamental, right? However, if I tell you with certainty, okay, for sure, I will give you this question and that question and that question, there might be the chance that you will only learn for these questions. I mean, properly. Nah? I'm not saying that for sure you will do that, but likely. Okay. So to avoid that, I randomize the set of questions. So I will choose or draw randomly from a set of possible questions in order to keep you learn more general for the exam. From your side, for example, because you're dealing with many exams, it could also be the case that your time to prepare for micro is limited. You can't learn everything. So you will also have a set of possible strategies and you randomize your learning now in order to prepare for the exam. So those are examples of randomization. In the summer semester, you will have more opportunity to get in touch with this concept. But then why do we have to study mixed strategies? I mean, something with certainty is much simpler, much more straightforward, and to our intuition, that is something that happened, or that is something we would like to think about ourselves. Being consistent, being decisive about what we do, right? However, there are many situations actually it's more natural to think about randomization, like the examples I gave you. And if you remember from last week, we have some games with no Nash equilibriums, like the rock, paper, scissors that I did in the video. There's no pure strategy Nash equilibrium in that game. But if we change the setup and now we allowed for mixed strategy, we will find one Nash equilibrium under the setup. Now, like I just said, is actually what happens more often in the background of reality in certain situations. We're not always certain about what we should or what we want to do. No? And there are other possibilities to circumvent such situation. However, it will involve more complicated setup with pure strategy. For example, you could turn it to an asymmetric information game where I know what my preference for question, I know with certainty, but you don't know. Or you know what your preference, how you think about the exam, but I don't know. But it will be more complicated rapidly as the game develop to many strategy and many players. So let's start with the mixed strategy and see how we solve for it first. Before we put it in a specific example and try to learn how to solve it, let's go first with some formal definition. Now, as before, we have several players in the game, and every player has a set up of possible strategies or actions. And now we denote that as a set of capital A with index I for player I, and with O small a with another index on the superscript for the strategy. So from 1 until n. Okay. So a mixed strategy is just a probability distribution over these m actions. And we could denote this mixed strategy as before, a strategy with s small I, where we attach certain probability for each of m actions. And we here let's first denote the probability of the first possible action is sigma I 1, and it goes like that until sigma I m for the m possible action of player I. Now, by definition, by construction of probability distribution, each of the probability of each possible action must lie somewhere in between 0 and 1. Probability cannot be negative, neither can it be larger than 1. And because it's a probability distribution, right? So the probabilities of all possible actions must sum up to 1. You can't have anything larger than that. All right. Then you may know already, defining it this way, a pure strategy is actually just a special case. Now, why is it special? It is special because, for example, here you play one strategy with certainty, means the probability for that possible action one, let's say, is 1. That means playing with certainty. And consequently, because here is 1, all the other probabilities for other possible actions must be 0. And that is the case for the pure strategy. It's just one special case of the general mixed strategy setup. So let's put aside that special case. For all other cases where you have 2 or more actions being played with positive probability, so all the probabilities in this set of actions are larger than 0, strictly larger than 0 and smaller than 1, then it's called strictly mixed strategy. Now go back to the notation of small si a bit. So if you set a certain probabilities for each of these possible action, then you got one mixed strategy. By changing the probability of at least some of these actions, you get another mixed strategy. So that's why SI must involve setting the probabilities for all the possible actions within that set. All right. Now we see how the payoff for the wife and the husband different in the mixed strategy version of, again, the battle of the sexes. Okay, so this is what written on the slide that I have introduced already. And here note that for also later use, I denote the probability that the wife would go for ballot is W for wife, equals 1/9. Why the probability for her to go to boxing is 8/9? Because we only have 2 possible strategies. Both must sum up to 1. So here I could write already that its probability of boxing is 1 minus W. And similar for the husband, denoted the probability that he would go for ballot is H, and boxing 1 minus H. So I would like first to show it on the extensive form of the game. Just again that I said somehow easier to illustrate. So the extensive of the game, let's start with the decision note of the wife, lady first. So here she go for ballot with the probability is 1/9, right? And then she goes for boxing with the probability 8/9. And then there come the decision notes of the husband. Let's use another color for the husband. So he would go for, let's say, husband. he would go for a ballot with the probability is 4/5, right? And then he go for boxing with the probability 1/5. A little bit narrow. Okay, and I just repeat it again. Maybe it must be a bit longer. Okay. My drawing is always not so nice. Okay. Similar. Ballot, 4/5. And then boxing, 1/5. Now, let's write down again, but before that, remember we in a simultaneous setup. So actually, the husband and the wife move at the same time, so that's why we need that dotted circle around. Yeah. So the first thing to write again is the payoff. It just as what I introduced to you last time. Now, if they go to ballot both, then wife got 2, husband got 1. Now, if they go separately, one go to ballot and one go to boxing, then both are nothing. So there are 2 scenarios in between 0/0. And then if they go together to boxing, then wife get 1, husband get 2. That's what we know, right? We have now the difference from before is we have the probability. So here we have probability of each strategies of each player. Now we calculate the probability of the scenarios, like one plays one strategy and the other would play another strategy. Now, so you may remember something from your math class. If not, there's plenty of chances to revise it next semester. But for now, so the probability that this scenario ballot happens equals the probability that the wife go ballot times the probability that the husband goes to the same 4/5, which is 4/45. Now, similarly, this scenario you have 1/9 of chance that the wife go to ballot and 1/5 of the chance that the husband go to boxing. So that is 1/45. Now, the next one, boxing ballot, boxing for the wife, A9 times ballot for the husband, 4/5, that is 32/45. And then both go to boxing. So A9 times 1/5, which is 8/45. So these are the probabilities for each scenario that happens. And then if you actually sum them up, I will have something over here. Okay. If you sum up across this column for the probabilities of each scenario, what would you get? 1, right? Because we only have 4 possible scenarios. So the probability for each of them must be something smaller than 1, and you sum 4 scenarios, you must get 1 by construction. What else would we have? We have now something called expected payoff. So expected or expectation is a concept within the rationality frameworks. When something involves probability, not with certain, then you have expected. Now, so not the payoff is certain, and now we have expected payoff. Let's calculate for each player with each scenario. So originally the wife would get 2 if she plays with certainty now. But now only this scenario only happens with 4/45 chance. Then her expected payoff would be 2, the original payoff, times 4/45, which is 8/45. Now, for the husband, he has 1 if he plays with certainty. Similar now with the probability of the scenario. His payoff here will be 4/45, right? And here is easy. Why? Because you have 0 times something. Don't even have to bother yourself. In the last scenario, the other way around, for the payoff, so for the wife, 1 times 8/45, right? Oh, sorry, 8. So that is 8/45. And for the husband, that will be 2 times 8/45, which is 16/45. Now, then the expected payoff for the wife I denote here as E with the index W for the wife. Yeah? What is that? It is the sum of these 2 elements that you calculated. So A/45 plus A/45, which is 16/45. And for the husband, EH would be 4/45, right? Plus 16/45. 16. That is 20/45. So here, what does expected payoff mean? Expected payoff is just simply the weighted average of the payoff with the weight being the probabilities of each scenario.